Hi everyone, we're going to start Module 2 today, and Module 2 is all about polygons. So let's start with that word. Let's talk about what that means. A polygon is any shape made out of completely straight edges. So some simple examples of polygons are things like triangles and squares. And then anything with a curve like a circle does not count as a polygon. So we're talking about things that have perfectly straight edges. Now, I said a simple example of a polygon might be a triangle, or I said square, but in the notes I put rectangle. But a polygon can also have a lot of sides. So for example, this is a polygon that has 12 sides. The name for that would be dodecagon, and it kind of almost looks like a circle. You know, when you have that many sides, they almost start to blend together and make it look like a circle. It's not a circle though. It is a polygon. It is, if you look very carefully, made up of straight edges, even though the sides are pretty small. All right, so just like when we talked about a triangle, any polygon has interior angles. A triangle has 3 interior angles, but polygons with more sides would also have more angles. So here's an example of a, let's see, 1, 2, 3, 4, 5-sided figure that has 5 interior angles. So you can see the words interior angles with little arrows pointing to them. They're all color coded. So you have the green angle, the blue one, the orange one, the pink one, and the purple one. But each of those 5 angles is called an interior angle because it's an angle on the inside of the polygon. That's what interior means. And that's going to lead us into our first theorem for today. Our theorem is about finding out the total number of degrees, or the sum of all of the interior angles of a polygon. And you can always find that number by doing 180 times, and then what you do is 2 less than however many sides there are. Or as a formula, it's 180 times n minus 2, where n is the number of sides in the polygon. So for example, let's say we had a 5-sided polygon like the one in the last slide, the one I just showed you with all the colored angles on it. If I wanted to figure out what those 5 different interior angles add up to, I would do 180 times 5 minus 2. Now 5 minus 2 is 3, so I do 180 times 3, it's 540. So in a 5-sided polygon, the 5 angles will always add up to 540 degrees. Now let's take a look at our dodecagon from the first slide. If we have a 12-sided polygon, and I do 180 times n minus 2, I do, well, 12 minus 2 is 10, and 180 times 10 is 1,800. So in that 12-sided polygon, where you have 12 sides and 12 angles, the 12 angles in that picture will always add up to 1,800 degrees total. So that's going to lead us into our first example for today. It's one of our solve for x questions, and we have a polygon where I labeled a bunch of the angles. So if I want to answer this question, step 1 is to figure out how many sides there are. So let's count them up. I got 1, 2, 3, 4, 5, 6, 7. This is a 7-sided polygon. Now once I know that, I can figure out the total for the angles by doing 180 times 7 minus 2. Now 7 minus 2 is 5, so this is 180 times 5, which gives me 900 degrees. All right, now what I'm going to do is I'm going to set up an equation by taking all 7 of the angles. Remember, if there's 7 sides, there's also 7 angles. I'm going to take the 7 sides, I'm going to add them all up, I'm going to set it equal to 900, and then solve for x. That's going to be the equation I want to solve. So let's do that. And this is how I'm going to do it. I'm going to pick one of the angles to start with. It doesn't matter which one. I'm going to start with this x right here. And I'm going to start adding. And what I'm going to do, just to make sure I don't miss any, is I'm going to go clockwise around the polygon. So in order, after the x comes 102, plus, and then we have 165, plus, and then 123, plus, and then we have an x plus 11, plus a 128 plus a 161, and then that's it, we're back to the x. So I'm going to set that equal to 900, and I'm going to solve that for x. Now when I go to solve for x, when I look at it, it looks messy, like there's a lot going on, but what we actually have is a whole bunch of like terms to combine. So when I start with the x's, there's really only two. I have an x here and an x here. If I add those together, I get 2x. So really when it comes to combining like terms, I'm adding up all these numbers. I'm doing 102 plus 165 plus 123 plus 11, don't forget the 11 in there, plus 128 plus 161. So I'm going to add all that together, and I actually already did it. It comes out to 690. So the two x's, x plus x is 2x, that's easy. All those numbers together in green that I underlined, if you grab a calculator and add it all up, you get 690. So that is what equals 900. See, now we have a nice easy equation to solve. I just need to subtract 690 from both sides to cancel that out. That's gone. It leaves just 2x, and you get 210 over here. Then you finish the question by dividing both sides by 2 to cancel out the 2 in front of x. And x is 105. 210 divided by 2 is 105. So x ends up equaling 105 in that one. And it was a two-step question. You had to first of all count up the sides of the polygon so you can use 180 times n minus 2 to figure out what all the angles add up to. Then add up all the angles, set it equal to that number, and actually solve for x. All right, so now let's learn another important new vocab word. If I call a polygon regular, if I talk about a regular polygon, what that means is it's a polygon where all of the sides and all of the angles are equal. So like a regular five-sided figure, it's a polygon with 5 sides, but it's more. It means each of the 5 sides are the exact same length, and each of the 5 angles are the exact same measure also. Now here's an example, here's some examples actually, of some of the common regular polygons and the names that go with them. So the first one is an equilateral triangle. That one kind of has a special name. That technically is just a regular triangle. Regular means all 3 sides are the same and all 3 angles are the same. But we have a special name for the triangle. We call it equilateral. We also have one for the square. I mean, really, the name that should be there, it should say it's a regular quadrilateral. Quad means 4. Quadrilateral means 4 sides. So a regular quadrilateral also has a special name. We just call it a square. Now the rest of them you can see. Regular, pentagon, and I'm going to go over some of the names here. Pentagon is a good one for you guys to know. Pentagon means 5 sides. Hexagon, that's also a good one for you to know. This is a regular hexagon or a 6-sided figure. A 7 is called a heptagon. I wouldn't really worry about that. It's kind of an unusual one. You don't really need to know the name. Octagon's a good one to know though. Octagon has 8 sides, so this is a regular 8-sided shape. 9 is nonagon. That's another one you don't really need to know. And then 10 would be, which you kind of can't see behind me. 10 is actually called decagon. And that's another good one to know. So of the ones I think you should know, of course we already know triangle, we know square, quadrilateral is a good one. I think you should know pentagon, hexagon, octagon, decagon. If you don't know heptagon or nonagon, that's fine. But it's good to know the names of the polygons. And that way, if it talks about one in the question, if there's a question that talks about an octagon, you'll immediately know it's an 8-sided shape. All right, so for our next example today, let's find the measure of each interior angle of a regular polygon with 10 sides. Okay, so let's start the question the same way we did the last one. I want to find out the total number of angles of a polygon with 10 sides. So I do 180 times 10 minus 2. And 10 minus 2 is 8. And 180 times 8 would be, let's see, 800 plus 640 would be 1440. All right, so the total is 1440. Now, a polygon that has 10 sides also has 10 angles. And here's the key. Because it's a regular polygon, they're all exactly the same. So the answer to this question, I'm going to take the total, which was 1,440. I'm going to divide it by the number of angles. There are 10 angles if there are 10 sides. And each one has to be exactly 144 degrees. But we can only do that because it's a regular polygon. The first example today, when all the angles were different and it was kind of twisted around like that, every angle was different. One angle might have been 100, another angle might have been 120, and another angle might have been 60. You know, every angle could have been different in this case, as long as they add up to 1,440. But because it said regular, we know they're all the same, and we can just divide by however many sides there are. All right, I have one last example for you. Remember when we did triangles, we talked about an exterior angle. Now, that applies for any polygon. So if I talk about an exterior angle, what I mean is if I pick any one of the sides, it actually doesn't matter which one. If I pick any one of the sides and extend it like this, then this right here is called an exterior angle. And this is what I want you to find. I want you to find the measure of that purple angle right there. Well, here's my plan for this question. Just like when I do a proof, I always like to have a plan. I'm going to find this angle right here first, because those two angles, the purple and the green, they form a linear pair. So if I know what the green was, or if I know what the green is, I can just subtract from 180 to find the purple. So I have my plan. I'm going to go back to the last example. In fact, I'm going to do the exact same thing we did in the last example. I'm going to figure out what each interior angle is, and then I'm just going to subtract from 180 and I'll have the exterior angle. So let's do that. This is a 7-sided figure, so if I want to do the total first, I'm going to do 180 times 7 minus 2. We actually already did a 7-sided figure once. Comes up to 900. Comes up to 900 degrees. All right, now, if I want to figure out what each angle is, I'm going to take that 900, I'm going to divide it by however many there are. Now in this case, there are 7 angles. That actually isn't going to go evenly. I'm going to pause for a second. I'm going to use my calculator again and get a decimal for this one. All right, so I did it. I got about 128.6 degrees, we'll call it. It was 128.57. We'll round it off to 128.6. Now, what I actually found is the green angle. So each angle inside this polygon, every single one of them is about 128.6. But that's the green one. So the answer to the question, the exterior angle, I just need to subtract from 180. We already decided they're a linear pair. So my final answer for this question, I'm going to do 180 minus 128.6, and that would be 51.4. So we found the exterior angle. It was very similar to what we did in the last example. Just make sure you know the difference between interior and exterior angle. For any polygon, an interior and an exterior angle always add up to 180. So if you find either one of them, you can get the other one just by subtracting. But that's what we're doing today. We're learning about polygons. We're finding interior and exterior angles. Sometimes it's a regular polygon, like the last two examples, and maybe sometimes it isn't, like our first.